Every year, scientists track thousands of asteroids that pass near Earth. Some of these are big enough to destroy an entire city if they ever hit, earning them the nickname City Killers. While none of the asteroids on this list are expected to strike Earth anytime soon, their size and close paths make them important to watch. From long-known threats to newly discovered objects, here are 10 city-killer asteroids that scientists are keeping a close eye on right now. 10. 2024 YR4, a potential lunar and Earth threat. Asteroid 2024 YR4 has been making headlines not because it's targeting Earth directly, but because it might strike the Moon. Discovered in late 2024, the asteroid is estimated to be between 174 and 220 feet wide, or about 53 to 67 meters, which is roughly the size of a Boeing 747. That's large enough to destroy a city if it hit Earth, similar to the 2013 Chelyabinsk meteor, which injured over 1,500 people, even though it exploded in mid-air. Initially, scientists were concerned that the asteroid had a 3.1% chance of impacting Earth in 2032. Fortunately, that probability has since dropped to nearly zero. But what makes YR4 fascinating and, still dangerous, is that it now carries a 4.3% chance of hitting the Moon on December 22, 2032. If it does, it could create a crater over a kilometer wide, visible through many backyard telescopes and even from lunar orbiters. Scientists hope that if an impact does occur, it could provide valuable scientific data. NASA and the European Space Agency, or ESA, are already considering how to use the event to study impact mechanics, lunar geology, and ejector dispersal patterns in real time. The asteroid's trajectory is still being refined, and it remains under active surveillance using radar, optical telescopes, and potentially even space-based assets, such as the James Webb Space Telescope. The fact that it was identified as a potential threat so soon after discovery really underscores how many objects like it remain undetected until they're uncomfortably close. While Earth is safe for now, YR4 is a sobering reminder that cosmic hazards often come with very little warning, and that even our Moon isn't immune. 9. 99,942 Apophis, the return of the Aten threat. Asteroid 99,942 Apophis was once the poster child for planetary danger. Discovered in 2004, this massive Aten-class asteroid, estimated at 1,082 to 1,476 feet wide, or about 330 to 450 meters, initially had a 2.7% chance of striking Earth in 2029, sending scientists, news outlets, and doomsday theorists into a frenzy. It was the first object to briefly reach a level 4 rating on the Torino scale, which is a rare and pretty alarming metric indicating a significant threat of regional destruction. That might sound mild, but Apophis is big enough to devastate an entire country. Thankfully, additional observations ruled out a 2029 collision. Instead, Apophis is expected to swing just 19,644 miles, or about 31,600 kilometers, from Earth, which is actually closer than some satellites. That close approach will provide scientists with an unprecedented opportunity to study the asteroid's structure, spin, and potential for future deflection. Already, NASA and other space agencies have been planning flyby missions, including ESA's proposed Ramses spacecraft, which may launch to observe Apophis during or after its close encounter. Despite being cleared for the 2029 approach, Apophis remains under intense surveillance. Some astronomers worry that gravitational interactions with Earth could slightly alter its orbit, possibly setting up a dangerous resonance for later in the 21st century. Although the current data suggests no impact through at least the next 100 years, the asteroid's size, orbital behavior, and, honestly, its eerie namesake, Apophis, is the Egyptian god of chaos, make it a perennial favorite in both planetary defense plans and Hollywood screenplays. Its passage will be visible with the naked eye, and a cosmic close call we'll all be watching. Asteroid 101955. Bennu is, honestly, one of the best-studied space rocks in our solar system, thanks to NASA's OSIRIS-REx mission, which actually collected and returned a sample from its surface in 2023. Bennu is roughly 490 meters wide, definitely large enough to destroy a metropolitan area. And, according to updated NASA models, it has a 1 in 2,700 chance of hitting Earth in the year 2182. Now that may sound pretty remote, but it actually gives Bennu one of the highest known impact probabilities for a large object. Bennu orbits the Sun every 1.2 years and makes close approaches to Earth about every 6 years. Scientists are especially interested in how solar radiation affects Bennu's path through something called the Yarkovsky effect, a tiny but cumulative push caused by heat emissions from its surface. This unpredictable force makes long-term trajectory modeling pretty difficult, which is part of the reason why Bennu's exact path in the late 2100s is still under close analysis. The good news is, we've got over a century to prepare, and thanks to the OSIRIS-REx data, more tools than ever to predict and prevent any possible impact. Even if Bennu never strikes Earth, it's already reshaped our understanding of asteroid dynamics, surface composition, and what a real-world planetary defense mission might actually look like. OSIRIS-REx revealed that Bennu's surface behaves more like loose rubble than solid rock, which could, honestly, complicate deflection attempts if the asteroid ever moves into a more threatening trajectory. For now, it remains a case study in both cosmic risk and interplanetary preparedness. Asteroid 2004. VD17 once held the title of the most dangerous known asteroid, at least for a brief period in the early 2000s. With a diameter of around 580 meters, it's definitely more than large enough to cause widespread destruction. Early projections put the odds at a 1 in 1,320 chance of impact in the year 2102, which led to it being temporarily assigned a Torino scale rating of 2. A pretty rare status that's usually reserved for objects needing serious tracking and impact assessments. But as more data came in, astronomers revised the probability downward, eventually eliminating the 2102 impact scenario altogether. Still, that hasn't taken the object off watch lists. Because of its highly elliptical orbit, 2004 VD17 frequently crosses Earth's path. Any future perturbations, whether from gravitational tugs by planets or solar radiation pressure, could still nudge it into a collision course over the next few centuries. It's honestly a classic example of why long-term monitoring is essential, even for asteroids that temporarily fall off the risk radar. What makes VD17 stand out is its combination of size, speed, and its prior risk level. While it's no longer considered an emergency-level threat, its history as a top concern really shows how quickly scientific projections can change. As asteroid detection systems like NASA's NEO Surveyor and ESA's FlyEye telescope come online, objects like VD17 will be re-evaluated in greater detail, potentially resurfacing as future hazards, or just reassuring blips in our increasingly crowded cosmic neighborhood. By the way, if there's any topic in this video that catches your eye, just comment down below and let me know if you want me to make a separate video on it. I'd love to hear your thoughts. Asteroid 125538, 1998, OH, is an Apollo-class near-Earth object estimated to be between 328 and 656 feet, 100 and 200 meters in diameter, large enough to obliterate a city and cause regional devastation if it ever made landfall. First observed in 1998, this asteroid has drawn attention due to two upcoming close approaches to Earth, expected in 2042 and 2132, with distances narrowing to just 0.03 astronomical units, about 2.8 million miles or 4.5 million kilometers. Though that sounds far, it places the asteroid within the category of potentially hazardous objects, PHOs, those that approach Earth within 0.05 AU and are large enough to cause serious damage. Its elliptical orbit crosses Earth's path every few years, and while current data doesn't predict an impact, the asteroid's trajectory remains sensitive to gravitational nudges and solar radiation effects. These subtle forces can alter orbits over time, especially over multiple decades or centuries. Because of its size and orbital behavior, 1998. OH is included in long-term planetary defense simulations, helping scientists refine impact modeling, response planning, and early warning systems. As of now, there are no mission plans to intercept or study it up close, but radar observations during the 2042 flyby could yield more accurate predictions for its 2132 path. If it were to ever veer closer to Earth, it would become an urgent priority for mitigation efforts. Discovered in 1990, Asteroid 4953 is another large and concerning Apollo-class asteroid that orbits the Sun every 1.5 years. It's estimated to be between 984 and 1,968 feet, 300 and 600 meters wide, making it significantly larger than the 1908 Tunguska object, which flattened 772 square miles, 2,000 square kilometers of Siberian forest. Classified as potentially hazardous, 1990 MU has several future encounters with Earth scheduled, most notably in 2027 and 2058, where it will pass within a few million kilometers. Although no immediate danger is forecasted, 1990 MU is being closely monitored due to its high orbital eccentricity and tendency to pass through the Earth's neighborhood. Like many other large PHOs, its orbit could be affected by gravitational interactions with planets or thermal forces like the Yarkovsky effect, which change its trajectory very subtly but significantly over time. Because of its long history of observation, it's a prime candidate for refining our understanding of orbital drift. Some researchers have suggested 1990 MU could become a target for a future reconnaissance mission, especially given its size and frequent proximity. As more near-Earth objects are catalogued each year, 1990 MU remains one of the better-known threats on the books. Not because it's heading our way soon, but because it's large enough to remind us of how devastating even a near miss would be if trajectories ever shifted. It's a quiet, massive rock, just a little too close for comfort. Asteroid 2007. FT3 is one of those rare cases where a once worrisome threat essentially disappeared. Not because it no longer exists, but because astronomers lost track of it. Discovered in March 2007, FT3 was initially given a relatively high impact probability for several future dates, including October 3, 2024 and October 2, 2030. Estimated at approximately 1,082 feet, 330 kilometers in diameter, its mass and potential speed made it a formidable threat, placing it briefly on NASA's Sentry Risk table as a potential city killer. However, the problem with FT3 is that it was only observed for a very short period before it slipped out of view, just 1.2 days in fact. That minuscule observation arc left a massive amount of uncertainty in its predicted orbit. While models could suggest dozens of potential close approaches or even impacts, the data was simply too vague to calculate anything with confidence. The result was a sort of statistical Schrödinger's asteroid, maybe dangerous, maybe not even close. NASA eventually downgraded the impact probabilities for all forecasted dates and removed it from high-risk classifications. But 2007, FT3 remains a cautionary tale. Even today, many potentially hazardous asteroids are discovered, briefly tracked, and then lost due to short viewing windows or poor sky visibility. Without constant vigilance and perhaps a dedicated space-based asteroid observatory, we risk repeating this scenario with a rock we won't have time to stop. Discovered in late 2023, Asteroid 2023 TL4 immediately caught attention due to its size, estimated 1,082 feet or 330 mm wide, and its long-term risk potential. Within months of discovery, scientists identified a 0.00055% chance of impact in the year 2119, placing it on the lower end of risk probabilities, but still notable due to its destructive potential. A rock of this size would unleash energy many times greater than the Hiroshima bomb, possibly leveling a city or causing widespread secondary effects like fires, shockwaves, or tsunamis. Like many newly discovered objects, 2023 TL4 was initially burdened by uncertainty. Small changes in its orbital path, caused by gravitational tugs or solar radiation, could significantly alter where it ends up a century from now. It's now part of a growing catalog of next-generation PHOs, potentially hazardous objects, that are being tracked with improved models. These asteroids are crucial to study not because they pose an immediate threat, but because they give scientists decades to test, refine, and improve long-term planetary defense strategies. More observations are needed to determine whether 2023 TL4 will eventually be removed from watch lists. But its discovery highlights the importance of global early warning systems. It's also a testament to the power of modern sky surveys. Telescopes like Pan-STARRS and Atlas are spotting these kinds of mid-sized citybusters earlier than ever before. TL4 reminds us that humanity is getting better at identifying danger, but still has a long way to go in terms of prevention. In 2024, a group of astronomers revealed that Venus may be hiding a group of potentially hazardous asteroids, some of which could be large enough to wipe out a city if their orbits ever shift. These co-orbital asteroids, which orbit the Sun alongside Venus, are particularly difficult to detect due to their proximity to the sun's glare. Earth-based telescopes have a hard time observing this region of the sky, meaning that some of these threats could be flying under the radar, literally and figuratively. What makes this class of asteroids especially concerning is their potential orbital instability. While they currently travel in relatively predictable paths near Venus, any gravitational interaction, say a nudge from Venus, Mercury, or even solar heating, could send them into Earth-crossing orbits over the course of decades. According to a study published in Astronomy and Astrophysics, at least 20 Venus co-orbitals have been identified, including some classified as potentially hazardous to Earth. One of these, 2020 AV2, is locked into a rare orbit that never crosses Earth's path, for now. This discovery has sparked calls for space-based detection systems, such as the upcoming NEO Surveyor mission, which will orbit the Sun in a way that allows it to observe objects near and inside Earth's orbit. Because city killers like these remain effectively invisible from Earth until they're much too close, detecting them early is essential for any meaningful defense. The Venus co-orbital group is a cosmic blind spot, and one of the best arguments for turning our eyes toward the Sun, not just the stars. In May 2025, NASA tracked 5 near-Earth asteroids, making close flybys in a single day. None of them large enough to end civilization, but several measuring up to 250 feet, 76 meters wide, or roughly the size of the Statue of Liberty. One of the objects, 2025 J01, passed within just 1.1 million miles, 1.7 million kilometers of Earth, a cosmic hair's breadth in astronomical terms. While none of these rocks were on collision courses, they illustrated just how frequently space throws fast, chunky surprises our way. Events like this are sometimes downplayed by the media, but among planetary defense experts, they are viewed as critical drills. Each close approach provides valuable data for testing tracking software, refining orbital models, and rehearsing emergency alert systems. Had even one of the 2025 flybys been on a direct course, it could have flattened a city or caused a tsunami if it struck the ocean. These events help researchers assess the effectiveness of early warning tools and highlight gaps in asteroid detection coverage, especially for fast-moving or sun-approaching objects. Perhaps most unsettling is how routine these events are becoming. Dozens of city-killer-sized asteroids pass near Earth each year, many discovered only days or weeks in advance. The 2025 cluster is a sobering example of how little warning time we might have if a true impact threat were inbound. It's also a call to action. Improve sky surveys, develop deflection technologies, and treat near misses not as curiosities, but as previews of what could one day be a global catastrophe. Wow, you guys have made it till the end of the video. And remember, according to YouTube, the best way to help the channel in the algorithm is to watch another one of my videos right after this one. So go ahead and check it out. Thanks for sticking around. See you soon. Until then, peace.